Good afternoon. Demi and I are out here in the technical area of Exactrix, right next to the flow lab, and we're going to explain to you today how to set the Exactrix Mustang opener for injection. And so let's talk about the basic components. Number one is the gyro counterweight. It's 10 inches in diameter. It's 3 inches wide. This particular model, of course, is a P51 CUE, and normally it has a 4-inch wide rolling counterweight. We have installed a smaller blade today. It's a 24-inch diameter blade, and I'll explain the story on this particular blade design. You can see it's pretty close to 7 inches from the counterweight, which means there's 14 total inches plus 10. It's a 24-inch wide blade, and the blade is actually set out and machined up to about a 375 thousandths width. You can see that width is about 375. So the edging occurs about 1.5 inches back, and if you look on the drawing up here, you can see the edge line. It's been done at 21 inches. So we know the relief here is at a slight angle. You can see that slight angle here where my finger's at. That angle allows us to penetrate in and cut. In the meantime, it leaves the injector foot in a blind area, about 3/8 of an inch in width. So this foot is sitting alongside the edge of the blade, and so we look down here and we can see the injector foot. Now this is not a knife, it is an injector foot. It purposely is designed to inject from the 4-inch level down to the bottom of the slot and leave a vertical band of nutrients. So there's about 2 inches of slot above it. So this is the zone of injection, about 4 inches total. There's 3 injectors on this unit. This is the liquid polyphosphate, this is the ammonia, and this is the third product injection. These are press NTIOs. So the purpose of this design is to mix these chemicals, these fertilizer materials, in a slot in the soil, but it doesn't all go to the bottom. It sits in a vertical band, so to speak. So there are some other components here that we need to talk about on the Mustang. This is the clamping assembly that adjusts the injector foot into position. We're going to slide it back and forth a little bit. This is called the check valve holder. It's mounted to the injector foot. And then we'll walk around on this side of the opener. And on the back side of the opener, you'll begin to notice there's some interesting components. The hub is held by a retainer, and it's shimmed into position, so we always get this blade on center line. And so this actually has a little shim pack that adjusts that spindle. And this is called the tool holder, and it actually has a pivot point right here, and there's another one that's hidden right up here. You can't see it, but it's a blind hole right now, right there, for a second position. And so you, as the blade wears, you can actually move the tool holder up into that position. And then on the tool holder is what we call the shark's tail, and this one is adjustable to get into different positions for blade diameter and blade wear. So this tool holder is designed to work with 26.5-inch blades as well as 24s. And we try to make certain that we set this shark's tail exactly in the sweet spot of a 26.5 or a 24-inch blade. But it is adjustable, and you can slide it back and forth, and you can mate up with these holes up here also in order to get your geometry right. Well, what is this linkage about? This linkage is a stabilizer arm. It runs in bushings, and it helps to hold the tool holder into place as you're going down the field at high speed. And the stabilizer is in an imperfect parallelogram, and which an imperfect parallelogram is a triangle. So the purpose of this is to have the opener move up and down. It's spring loaded here. This moves up and down independently, and this injector foot moves in this imperfect parallelogram and makes certain that the rock does not interfere or contact the injector foot as it walks over the sub-located rock. So these three holes here are used to carry the rolling counterweight if you don't want to run it in a rolling position, but it keeps the weight on the unsprung side of the spring. So we're going to go back around on the other side here. These bolts, by the way, are the rocker arm bolts for adjustment of the angle of the injector foot. It's called the rocker arm. This is the rocker arm. I have my hand on it, and you can see it's slotted. It has 3 bolts actually that retain it, and you can change the angle of the injector foot with this rocker arm. It's all grade 8 hardware and swedge type nuts for self-tightening. So we're going to illustrate now some of the positions of the opener. And so Denny, let's we'll pull this bolt here, I'll lift it, hold it, and we'll go to the upper position of the shark's fin and shark's tail there, and we're going to adjust. And watch this line right here, this 4-inch line. And we came down slightly, and that gives us a little lower adjustment and allows this shark's tail to be highly utilized in getting the correct adjustment for the injector foot. There's 3 positions of it, and of course as you wear the blades down you like to quickly adjust, and this is a good place to go to make an adjustment. There's also an adjustment here in the injector foot, and let's go ahead and break the bolts and we'll slide this out of the way. So you can adjust this foot back and forth based on positioning, and we're going to start this unit out with a maximum angle on the rocker here, and we're going to hold it right into position like that with a nice overlap. We're going to end up with about a 1/2 inch, and this is designed to rub against the blade, but there's a little bit of free play right in here from this bolt on the other side that retains the tool holder. We get a little bit of free play, so this acts as a scraper, and so if the mud is rolling around it tends to hit this blunt edge right here and kick it out of the way, and yet the polyphosphate can inject forward at this angle. So this is really a scraper as well as a injector foot. So once again you can see that it rolls freely, and we have found that this injection point works about the best. So in the design of the opener, it must run deep. It must go in about 6 inches. We try to get it to actually even roll on the gyro counterweight, so it directs the flow of soil and or any residue that might carry around, comes off and shoots off to the side away from the holder, the tool holder. So single edging has some really excellent advantages in going through tremendous amounts of residue and is originally where our design started. There's one slight negative fact about the single edge design is that this flat edge on the back side will tend to flip. Every now and then it'll flip some soil. So as the opener is swiveling, as it's going down the field, the advantages of a gyro is it tends to drive the opener straight ahead. It tries to keep the opener from shimmering or shimmying, and this design has been very successful in producing low disturbance banding of anhydrous ammonia, polyphosphate, thiazole, and other products. So I think that concludes our presentation, Alex.